We are finally done with the review of algebra, and we are moving on to geometry. And so we're starting off with chapter 1 here, understanding points, lines, and planes. And I am going to let you know there's a lot of vocab in this section that we need to talk about. Some of it you already know, but some of it you're going to have to write down for your notes. And there's going to be what are called postulates later on, and those are definitely going to have to be written down because those are going to be answers to some questions that you will have in your assignments in the future. So starting off here, we have undefined terms. Undefined terms in geometry are the most basic figures. Those are points, lines, and planes, and they cannot be defined by using other figures. So those three things are considered undefined terms. A point names a location and has no side. And we simply label them with capital letters. So we could have point A, or we could have point Z. Sometimes we write the word point in front of them. So maybe we have point M. And then next is a line. A line is a straight path that has no thickness and extends forever in both directions. So this is what a line would look like. And it has to be labeled with at least 2 points. And we will call it R and S, those points. And when you label a line, you have to be really careful. You use the 2 letters that are on the line. So in this case, we have an R and an S. And then the label above is a line with arrows at both ends showing that it extends forever in both directions. You have to have those arrows in order for it to be a line. Okay. A plane is a flat surface that has no thickness and extends forever. So I guess kind of think about it as your piece of paper, but it extends on forever. It's your flat surface where your lines are, your points are, your segments, your rays, all of those things is a plane. And a lot of times there is a italicized letter or more of a cursive looking letter in the corner somewhere that is used to label those. So I will do my best to kind of show you. There's a little fancier R. And if this had 3 points in it and they were called A, B, and C, we could do one of 2 things. We could call this plane R, oops, not A, plane R, or we could call it plane ABC because it contains those 3 points. And then we have what is called collinear and coplanar. Collinear are points that lie on the same line. So if I had a line and we had 2 points on here, maybe G and H, and then we had another point over here called I. G and H, those 2 points are collinear because they are on the same line. If I were to say points G, H, and I would say that they are non-collinear because they are not on the same line. And then coplanar is kind of the same thing, except for you're talking about a plane. So if all of the things that you're talking about lie on the same plane, then they are coplanar. If one of them is off of that plane, then they're non-coplanar. So example 1 wants us to refer to this design over here in the roof of Beijing's National Stadium. And it's kind of blurry, but you can kind of see the different pillars and things going on there. And they want us to name 4 coplanar points. So 4 points that are on the same plane. So as you can tell, there's two different shapes there. The pink triangle is a plane in itself because it's closed off there. It's one spot. And then the yellow is another one. And the yellow one actually has the 4 points. So that's where we want to look. Those 4 points are all on the same plane, and that plane is labeled with that cursive R there. So name 4 coplanar points. I would just write K, L, M, and N. And then part B says named 3 lines. Well, that's where I want to direct my attention to the pink triangle. As you can see, all the sides are lines that have arrows at both ends extending forever. So one of those lines could be from A to C. So we're going to write AC, and we're going to make sure that we have a line with arrows. Another one is C and B there, and we can put them in order of CB or BC, it does not matter, for a line. And then our last one is from B to A or A to B. We just want to make sure we label correctly. We have that line with arrows at both ends. All right, 4 more vocab words here. The first one is a segment or line segment, and it's the part of a line consisting of 2 points and all points between them. So a line segment is just a part of a line. It's between 2 certain points. So if I draw this line here, and I have 2 points on it, and let's call them A and B, and I want to say segment AB, I would call it AB or BA, it doesn't matter. And then it just gets a straight line, no arrows, because we are only talking about the piece between the 2 points. Those are the line, that's the line segment here. An endpoint is a point at one end of a segment or the starting point of a ray. So in that line I just drew, we have an endpoint A and we have an endpoint B. It's where it stops. And my next vocab word is array. And the starting point of that is also called an endpoint because it stops there. It doesn't go past that point. So array looks like this. We have a point with an arrow. This point could be called A, and we have another point on that ray somewhere, at least another point. We'll call it B. So that's array. It starts at point A and continues through point B forever in that direction. It doesn't go in both directions. It only goes in one. And the way we label that ray is we have to start with its starting point, which is A, and it continues through B, and then we draw the arrow that way, or the line with the arrow pointing that direction. We cannot call this ray BA. That is not correct because it does not start at B and go through A. And then opposite rays are 2 rays that have a common endpoint and form a line. So a visual for that would be a line with 3 points on it. And we'll call them A, B, and C. So we have ray BA, and then we have ray BC. So they share the endpoint B, but there's a ray in both directions. So for example 2, we're going to draw and label the following. The first one is a segment with endpoints of U and V. So here's an endpoint, U and V. It's that simple. It's a segment. It stops. There's no continuing on. And we are naming those endpoints U and V like said in the direction. The other one we have to do is opposite rays with a common endpoint of Q. So this one is going to get arrows at both ends because it has to have 2 rays. It says the common endpoint is Q, and then we have to have at least another point on each ray for the ray to go through, and maybe R and S. They didn't tell us what those had to be labeled. All right, this is the part that we have to write down, these postulates. It's a statement that is accepted true without proof. So we have 3 of them right here to look at. We just know that these 3 are true. We don't have to prove them, but we do have to know these numbers that go with them. This 1, 1, 1 says that through any 2 points, there is exactly 1 line. Okay, and then the next one, 1, 1, 2, says through any 3 non-collinear points, there is exactly 1 plane containing them. So non-collinear means they're not on a straight line. There's exactly 1 point, or sorry, 1 plane. So if you kind of draw a picture, there's going to be 3 points on it that are on the same plane. And then our last one, 1, 1, 3, if 2 points lie in a plane, then the line containing those points lies in the plane. So if the 2 points are in the plane, then it would only make sense that the line going through those 2 would be in that plane as well. Okay, so pause the video, make sure you have those written down because they will come back up in some of your assignments later on. All right, example 3 says name a line that passes through 2 points. And we have to kind of look at this picture that did not work out so well for me. Kind of blurry, sorry about that. Looking at it, I only see 1 line. It's going straight up and down. And it goes through the points GH, but then I see also that there's this little N right here. So we can say one of 2 things. We can say line N, that passes through the points G and H. Okay. The other thing that we could say is simply line GH and call it and label it correctly. Okay. And then part B says name a plane that passes through 2 points. We call this one of 2 things. We could say plane GHF because it contains those 3 points, or we could say plane R and attempt to write that fancy R. Now we have 2 more postulates. 114 says that if 2 lines intersect, that they intersect at exactly 1 point. So if you think about that, I have a line and another line. They can only cross at 1 point. There's no way to draw 2 lines intersecting at more than 1 point. And then 115 says that if 2 planes intersect, they intersect in exactly 1 line. So again, kind of a 2-dimensional. There's 1 plane, and I'm gonna do my best. And they would kind of form an X, but like 2 pieces of paper crossing, and they're gonna have a line where they are at. It's very difficult to try to draw that and show you, but same situation as the lines, only they are with a plane. So they only intersect in 1 line. A little tidbit here, you need to use a dashed line to show the hidden parts of any figure that you are drawing. So if something is hidden by something else, then we draw a dashed line. So if I were to draw a cube, these parts back here you couldn't see from the front, so you would draw those with a dashed line. That's all that means. Example 4, sketch a figure that shows a line intersects a plane but does not lie in the plane. So I don't run out of time here drawing, but we have our plane R here, and this line is coming up through the bottom. That's what those dashed lines show underneath, coming up through the top, and then the solid line is through the top where we can actually see it, and that is line L.